How did this happen? What you are looking at is a highly unusual type of meteorite whose mere existence tells quite an interesting story. Just looking at it, there are numerous pieces of a natural and metallic iron-nickel alloy which by weight is generally 90% iron and 8% nickel. This part of the meteorite originated from the deep core of a large differentiated asteroid or planetary body in the early solar system. Now, here is where it gets weird. The rest of the meteorite, in other words the non-metallic portion, is largely composed of silicate minerals, mostly pyroxene and plagioclase. This part of the meteorite formed on a large asteroid's surface or crust. So, why exactly does this group of meteorites, known specifically as a Mesosiderite, contain pieces of both a minor planet's core and crust, but not its mantle? I want you to think about this for a second and what might have caused such a strange combination of materials. After all, there are no pieces of Earth's core in the crust, while there are pieces of its mantle in some of its crust, specifically in what are termed Mantle Xenoliths, which can be found in the deposits of certain active, dormant, and extinct volcanoes. Take, for example, this specimen I own from Arizona's extinct San Carlos volcanic field. It was emplaced 580,000 years ago when a volume of rising molten rock carried with it pieces of our planet's solid olivine upper mantle upwards, eventually being erupted in a lava flow. Since the minimum size for asteroids to become differentiated into having a crust, mantle, and core with different compositions is 40 kilometers or 24.9 miles wide, could some form of volcanism have carried pieces of the core to the surface on a minor or dwarf planet? Almost certainly not. Instead, Mesosiderites have a different origin that involves a process far more violent and energetic than a simple volcanic eruption. Specifically through the impact of another large differentiated asteroid on a minor planet that is both unusually large and has a comparably thin mantle. This was modeled to be most likely in a so-called hit-and-run type collision as simulated in this diagram where a hypothetical 306 km wide circular asteroid impacts a 583 km wide asteroid. In the resulting collision, the smaller impacting body is essentially completely annihilated, with its remnants being flown off into deep space. Meanwhile, the sheer magnitude of the impact breaks apart much of the larger asteroid down to its core, ejecting clumps of its core, mantle, and crust. Resulting combinations of these falling back to the asteroid due to its gravity could then lead to the creation of both pallasites when mantle and core fragments combine, and Mesosiderites when fragments of the crust and core combine. If you are wondering what you get if all three fragments combine to create a resulting piece, you still technically get a Mesosiderite, as some Mesosiderites do contain enough olivine crystals that it is deemed at least part of it originated from the mantle. However, once again, the relative lack of mantle fragments in meteorites which aren't pallasites or meteorites that completely originated from a differentiated asteroid's mantle is still an open and unsolved geologic problem of great importance, with that being known as the missing mantle problem. I have a previous video on that subject linked here. But, back to the topic at hand, such a hypothetical large impact can create an unevenly thick crust with few exposed mantle fragments on the surface. And do you know which main belt asteroid perfectly fits that description? Vesta. Vesta is the second largest asteroid in the main asteroid belt and is oblong, measuring 464 kilometers long from pole to pole, but having an average equatorial diameter of 570 kilometers. Its crust is of a variable thickness and unusually thick for what would traditionally be expected. Adding to this, Vesta, much like other objects in our solar system that have experienced an incredibly large impact in the distant past, has a storm tilt, specifically of 27 degrees. And to some scientists, such an impact on Vesta 4.5 billion years ago, around the same time Earth's moon formed, is the source of all or most Mesosiderites that have been found to date. However, other scientists disagree, suggesting, for example, an origin on or related to the asteroid Psyche or Maria. As a final note, I would like to thank this channel's supporters on Patreon and our YouTube members for supporting my work.